Okay, so let's talk about 3D engine. So we structured our wrap up in two parts. The first question is where we started and where we are now after 4 days. And where we started actually was not with starting with Wednesday, but before, when Tebjan and Dottore decided to have a look into Xenco as a solution for a 3D engine for a certain project, right?
Yeah. Actually, we started with looking at what is available on the internet, which works together with .NET. That is our technology that we use for VR. And we had a look at a few libraries, and Xenco was standing out a lot because it was super advanced, it was high-end, it has a lot of technologies that everybody wants to have, like 3D import, high-quality materials, and it was using .NET and C# as the actual language it is written in. So it was very interesting for us to see how far we can get with it, and we tried the first proof of concept, and Nathan visited us in Berlin for 2 weeks, and we came pretty far. We designed a few pipelines, and it was looking very good. But then we didn't know how the licensing situation was, because back then Xenco was a commercial project from a studio in Japan, and the license was you could use it if your studio makes less than 20,000 revenue per year. So that wasn't really cool to have this as the default 3D engine, because normally most studios have a bigger revenue, so there would be a need to pay a license fee. So we didn't go further with it, but they said, okay, we'll have licensing discussions. So Xenco said that officially, and we'll have a result soon. And this took like 3 months. And luckily, a few days before Link, they came out with this amazing news that now the whole engine with the editor is MIT.
So, okay, so license was one issue, but at this point it was checked, and then
it was part of the first day. We talked about licensing issues and
exactly, and then some ideas came up, or some question came up. I think MicroD, for example, asked why not use a more low-level API, and then luckily.
Low-level API means in that way like DirectX 11, where you connect shaders with geometries, where you have buffers, and not a high-level engine that has like shadows and everything. So low-level is like directly talking to the graphics card.
But in this case also to have an export then as a multi-platform solution, because there are some around, right, like
Veldred, for example.
And the good thing was when we started to prove or make proof of concept or started to collect needs our 3D engine should solve or fulfill. This was one aspect, like the low-level API, and Xenco has this as well. So there is a way to also go in on a low level, but you have some more additional features which a pure low-level API didn't have. So let's collect them maybe. So we have the low-level part, like the low-level API, right? You have the whole game studio in case you want to do editing and loading assets, build scenes inside, so you have a whole studio around it, like an interface, not only a API for 3D engine, but also like an interface for everything. Which you can edit the scene graph, or can build scenes, multiple scenes. And also you have the material. This was one big topic, how to deal with materials.
Like Substance Designer, for example, which develops or is kind of an industry standard, and everybody kind of has the need to import a model in the standard sooner or later.
Already mentioned, but I write down as a single bullet assets and animation import. So this was a huge need or wish on our whole list, how to, if we go for a certain engine, we want to have something like this, like a import of FBX, animation, 3ds, different files, different standards. And there are a couple more, like multi-threaded engine, which you noticed that it's really well implemented, the whole multi-threading and Xenko, the performance is really good. So at the end of the first day, we all said, okay, Xenko, question mark, no, let's go this direction. So because it's,
it's cool because we have this low-level API inside. We could just take a small part of it, like only 5 assemblies, use this, and we would be happy. We could build something like the DirectX 11 nodes with it, and everybody would like feel at home because it would be the same nodes. But optionally, we could like use all those amazing high-level features that we would need years for to program. So of course, it was like when we discovered, yeah, it's cool. We have this no licensing issue. We have the low-level API we need at some point. What, 4 minutes? Yeah, and then all the high-level stuff optionally.
Okay.
So we said, yeah, okay, let's try that.
Okay, and so this was the first day. The decision, let's try this way. Let's look further. And with this decision, we started to collect on the second day the next steps and kind of tests we have still to make sure that Xenko is really the way to go. And on the other hand, there was a wish list of features when we start the implementation of Xenko as a 3D engine in VL, what we need to build on our own, what we need to build actually. And
so it was
there was 2 lists.
Yeah, trying to sort all what everyone has in mind and what needs to be done into 2 lists. What tests we need, because of course that as a creative coder, you have different needs than game designers. Of course, Xenko is made for game designers, so have much more exotic output needs than game studios. So that's a lot of tests you have to do, or we have to do, everyone maybe can do. And then of course there's a lot of work to wrap the low-level API nodes and the scene graph nodes into something that is easy to use, similar to, for example, Skier also. And there's a lot of work.
Yeah, and I just write down 3 of a bunch of them, which are on the list of tests we all can make from now, or at least from the moment when we have a certain implementation as a starting ground for tests. So, for example, one of the first wishes have been or tests and things to check the multi-screen support. Is it possible to have multi-renderer out of one scene, or is it possible to have different scenes and then different renderer? So this was one big issue to look into. Non-real-time rendering, resolution and vertex limits. And there are a bunch more we collected in a forum thread. And as I mentioned, there's a second list, or at the second day we started a second list, and they have been this list of features or tasks, you can say. And this is actually a pretty long list.
Which is also in the forums.
Yes.
You can look it up in detail in the forums, in this 3D engine thread of link.
So,
actually the list is there 2 times. One was the unordered list from the the second day, And then on the third day we try to prioritize it and also to organize it in also user groups. What has to be done by us, what has to be done at Praxis by the VR developers, and what can be done by anyone, what can be done by someone who has strong C# skills, and that this can benefit from a community. So that is very important.
I try to write faster.
2 minutes.
Yeah, I just put some examples just to show you what we thought is maybe a good
good order or priority list.
So as Tebjan said, so we have this one node set which is clearly on the side of the core devs, like the VL devs. So like graphics API nodes, iGPU image support or implementation scene graph nodes. And then for example like mesh animation import or multi-scene graph, we see more on the side of maybe programmers, external ones, or even studios. So it's kind of the same. And also and in the first group of contributors to the whole implementation could be users, like everyone of us, implementing certain features we already have now with the DirectX 11. Like one big example is GPU particles. This is not related to really low-level stuff. It's using the whole thing at the end and make something usable at the end.
Like contributions.
Yeah,
and also like texture effects, that you have the easy texture processing chains or geometry processing chains.
Yes, and actually this is the result. There are far more, and also you can find it in the forum. And this is kind of a first roadmap of features, or at least priorities of features we all think which are necessary. And we are standing now there at this point to find, I think the next task is to find the programmers and the users who are willing to do it, certain parts. And also the next step is of course the project you and Nathan already started, which is going to be...
We didn't start it, but we will like do a project with it, and there we will of course do a lot of tests. So this kind of first approach, we try to do something, apply it to a project and see how good and far we come with it.
Yeah. And so, because the project has kind of a deadline, which will be in November, the plan is that maybe in November there are some nodes already, which maybe then already everyone can use without any documentation at this point, and then to start to work on their own on next features.
So the hope is that this project will like reveal things and gives us confidence and an overview about over the engine, and that hopefully we can share something that is kind of a little bit usable for everyone, that we get feedback and everybody can get involved to design something, and also can just communicate their needs, that we know where we should go with it. Yeah. So mostly theoretical. We did one little test with MicroD, and we were able to set up the whole engine only by code, which could be also be patched in VL, and we rendered a little triangle.
Okay.
Yeah. If you have questions, yeah, please. Yeah.
Sounds really promising to me. I'm not really aware of the MIT license. Maybe there are plans to do a standalone of VA at some point. Would it allow to recompile only part of the engine into new executables?
Yeah, exactly. Yeah. Yeah.
Just wondering about it.
So what I understand from Zenko, they even plan to have Zenko just as a nugget distribution, that you could just install it on top of your project and use parts of the engine or the whole engine, which would be super cool for every developer.
That's great.
More questions, input? let's see.
Great summer.
There we go.
Okay, thank you.